Assalamualaikum warahmatullahi wabarakatuh. Today my group and I will be presenting about experiment 4, which is linear motion. I will start with the introduction. Linear motion is the movement of an object along straight paths either at a constant speed or with acceleration. In this experiment, we use a motion sensor to observe how a glider moves on a linear air track. By analyzing position versus time and velocity versus time graph, we aim to understand the relationship between force, mass, and acceleration. This experiment also helps reinforce the use of kinematic equation to describe motion in real-world system. Now I will move to the objective and apparatus. There are two objectives in this experiment. The first objective is to investigate the relationship between force, mass, and acceleration. The second objective is to determine the acceleration of an object under a varying force. The apparatus that we use for this experiment is air track rail, blower, pressure tube, gliders, flag, photogates, masses, mass hanger, string, and a pulley. Okay, I will pass the rest of the slides to my team members.
Now I will continue with the procedure. We set up the linear air track as shown in the manual. After turning on the blower, we balance the track until the glider remains when it releases. We attach a flag to the glider and connect it to a mass hanger using a string over the pulley. Different weights were added to the hanger to apply different forces. The photogate measures the motion of the glider. We record the data for position, time, and velocity to calculate the acceleration. Next, I will pass to my group mate.
For the result, this is the experimental data for the experiment 4.1.
The first analysis question, we must plot a graph of weight force versus acceleration. So as you can see here, the graph is straight line through the origin. So what does the graph tell us? The functional relationship between force is directly proportional to acceleration. Without systematic error, the relationship should be linear between force and acceleration. This will prove Newton's second law. For the third analysis question is to determine the gradient of the graph. So as you can see here, we got 0.034 kilogram, and the fourth question is to calculate the uncertainty of the gradient. So we can find the gradient by uncertainty of the gradient by finding the mean gradient and max gradient, and then max gradient minus mean gradient divided by 2, and we got 0.015 kilogram, and the last answer to this question is 0.034 plus minus 0.015 kilogram. And for the last analysis question is to briefly explain the relationship between the gradient from the graph and total mass. So the gradient of the line represents the total mass of the system. Relationship is direct result of Newton's second law of motion, which states that force equals mass time acceleration.
For discussion, we have to calculate the percentage difference between the gradient m and mg. We have to find the percent error in this experimental value. First, we have to find mt2, which equals to 0.0301 plus 0.0501 plus 0.701 plus 0.0901 and divide it by 4, which equals to 0.0601. And for MT1, we have to plus 0.2794 plus 0.2594 plus 0.1594 plus 0.1394 and divide it by 4, which equals to 0.2094. And with that, we have to find the total, which MT1 plus MT2 equals to 0.2094 plus 0.0601, and the answer is 0.2695. Moving on, we have to find the percentage difference, and the formula is m minus mt over mt times 100%. And for the calculation, 0.034 minus 0.2695 over 0.02695 times with 100%. And the answer is 0.8783 times with 100%. And the final answer is 87.83%. And now I will be talking about the factors that have been contributed to the errors in the experiment. One of the factors that have been contributed to the errors is misalignment of string and pulley. It happened when the setup are not properly aligned in a straight path. This causes unintended force or friction that affect the motion. Second is equipment doesn't calibrate properly. This can introduce systematic error leading to inaccurate reading. Third and lastly is calculation error. This happens when rounding the reading or the data. This can cause inaccurate calculation. And now I will be explaining on how to overcome the factors mentioned in the previous slide. To fix misalignment, make sure the string is straight and the pulley is properly aligned. Calibrate the spring scale before starting and check that the table is level to avoid wrong readings. Record measurements carefully without rounding too early, and double check calculations. Clean the surfaces and pull the block slowly for consistent results. Doing multiple trials and taking average will also help to reduce errors.
Lastly, I will continue with conclusion. In conclusion, the experiment was successful in demonstrating linear motion and Newton's second law. The results show that acceleration is directly proportional to the applied force. Although we face some experimental error, the overall data support the theoretical concept. This lab helped us better understand motion in straight line through real-world application. That's all from us. Thank you.